Hey everyone, welcome to Edureka's YouTube channel. My name is Wajiha and today I'll be taking a session on arrays in Python. So I hope everyone's ready to head start this session. So let's move on. In this session today guys, I'll be covering the following topics. First of all, I'll be explaining what exactly is an array. And then I'll be differentiating between Python lists and arrays. Now this is a very common question that many of us ask. After that, I'll be showing y'all how to create arrays in Python, following which we will try to access array elements and then we will try to perform some basic operations on arrays such as finding the length of an array, adding and removing elements from it, array concatenation, slicing and looping through an array. So I hope everyone's clear with this agenda. Now let's move on towards the first topic. Our first topic for this session is what exactly is an array? An array is basically a data structure guys with ordered series of elements. Any variable that is declared as an array can hold more than one value at the same time. All values in an array have a particular address which is specified by its index number. Here, as you can see on the screen, I've declared a variable a as an array and I've stored values from 1 to 100 in my array which is a. Also make a note of the index values. Indexing always starts from 0 and not from 1. Therefore, a of 0 holds 1, a of 1 holds 2, a of 2 holds 3, and similarly a of 99 holds 100. When the length of my array is n, the index value will be n minus 1. It is always 1 less than the length of the array. So I hope you're clear with this topic. Anil has a question. He asks, what does ordered series of elements mean? Anil, ordered series of elements means that every element is present at its particular address and this address is specified by its index value. So in case I have two elements that are same, for example, if a of 1 has 2 and a of 2 also has 2, both these elements are unique pertaining to their index value and they are ordered by the index values or addresses. So I hope I've cleared your doubt, Anil. Just give me a confirmation. Okay, Anil says yes. Now let's move on towards our next topic for this session, which is the difference between Python lists and arrays. Python lists and arrays have the same way of storing data, but there is a key difference that you all have to note. Arrays can store only single data type values, whereas lists can store any data type values. So for example, if I have an array of integer values, all values present in that array will be integers and nothing else. On the other hand, if I have a list, then it can store integers together with float and chars and strings, etc. Now when you try to perform some operations like slicing or looping, it will be similar for both. But when you try to perform different operations, like if you want to multiply your array values by 2 or you want to divide it by 2, you can do so easily when you have an array. But if you try to do the same with a list, it will throw an error because naturally you cannot multiply chars and strings or divide them. So I hope you're clear with the difference between these two. So now let's move on towards the next topic, how to create arrays in Python. Unlike other programming languages, if you want to create arrays in Python, you will have to import the array module. Now this module has all the functions that are necessary for creating and performing various kinds of operations on arrays. To import the array module, you can use three ways. First is to import the array module by its original name, which is array. The second method is to use an alias name. This is the most widely and commonly used method as well. In my demonstrations, I'm going to be using this method. The third way is using star. From array import star. What this does is it's going to import all that is present in your array module. Now let's go to our Jupyter notebook and try to do this. Please do it along with me, guys. I'll open a new notebook and I will use the first method to import the array module. As you can see, when I hit run, no error has been returned, which means this is executed. Now let's try to create arrays using this method. As you can see over here, I've created an array A using the first method. So I have used array.array of integer values and I've specified some random integer values. Here the first array is the name of the module. The second array is the array constructor. And then I've given a type code. This type code specifies what type of elements my array will hold. As you can see, I've created an array. So I hope you're clear with how to create arrays using the first method. Now let me open a new notebook and try the second method. The reason to open a new notebook is because I've already imported array module in this notebook. I'll rename this notebook because I'm going to be using this method in further demonstrations as well. As you can see over here, when I use import array as ARR here is my alias name. When I use this and hit run, it does not throw any error. Now let me try to create arrays using this method. I'm using int as my data type. You can use any data type of your choice. As you can see that an array has been created with some random integer values. In place of the module name array, I've used ARR. Now let's try the third method. I'll open a new notebook again. As you can see over here, when I'm creating arrays using the third method, I've just specified the constructor name and then the type code and the value list. So I hope you're clear with how to create arrays using all three methods. Okay, so now let's get back to our presentation. Our next topic for this session is accessing array elements. To access array elements, you'll have to make use of the index values. Each index value holds a unique element. Like I've told you before, indexing starts from 0 and not from 1. So therefore, A of 0 holds 1, A of 1 holds 2, and so on. This is the normal traversal order which starts from the left-hand side and moves towards the right-hand side. But here, I want you all to note this point as well, that negative indexing also exists. So negative indexing will start from the right-hand side and move towards the left-hand side. Therefore, 100 will be at A of -1, 99 will be at A of -2, and similarly 1 will be at A of -100. So I hope you're clear with negative indexing. Now let's go to our Jupyter notebook and try to access some array elements. As you can see over here, I've created a heading. To create a heading, all you have to do is go to code, select heading, and prefix your text with the number of hashes based on the heading level you want. So if I want h1, I will use 1 hash. If I want h2, I will use 2, and so on. Here I've created a heading of h1, so I prefixed my text with 1 hash. Now let me try to access some array elements. As you can see over here, when I access A of 2, my output is 3. Let's see where 3 is present in my array. 1 is present at A of 0, 2 at A of 1, and 3 at A of 2. So therefore, when I access A of 2, 3 has been returned. Are you guys clear with this? Just give me a quick confirmation before I move on towards the next topic. Shashank says yes. Preeti says, please try to access something using negative index values. Okay, Preeti, let me show you that as well. So here I've tried to access A of -2. A of -2 has returned 5. Let's get back to our array A and see where 5 is present. 6 is at A of -1 and 5 is at A of -2. Therefore, my output is 5. So Preeti, are you clear with this? Okay, Preeti says yes. Now let's move on towards our presentation and see what is the next topic. Our next topic of this session is basic array operations. Here, I just want to tell you all something. Arrays are mutable, which means they are changeable. So in case you want to add or remove elements from it, you can do so easily. Now coming back to our presentation, our first operation under this section will be finding the length of an array. The second is adding or changing elements of an array. And then we will try to remove or delete elements of an array. And then guys, we will try to perform array concatenation, slicing, and finally we will be looping through an array. Now let's move on towards the first operation. To find the length of an array, you will have to make use of the len function. Now this function returns an integer value which is equal to the number of elements that are actually present in your array. The len function takes one parameter which is the name of your array. As you can see in the example over here, I've created some random array A and I've given some random values. As you can see, I have 3 values over here. And when I use the len function and I specify the name of my array, the output is 3, which is equal to the number of elements that are present in my array. Now let's move towards our Jupyter notebook and see how this works. As you can see over here, when I use the len function and I've given the array name which is A, an integer value is returned which is 6. 6 is the number of elements that are actually present in my array which is A. Okay, so I hope you're clear with this. So our next operation is adding elements to an array. In case you want to add elements to an array, you can do so using the append, extend, or the insert function. The append function is used when you want to add an element to the end of your array. The extend function is used when you want to add more than one element to the end of your array. The insert function specifically adds a new element to a particular position in the original array. Let's have a look at a small example of these 3. As you can see on the screen, I've created some random array A, and then I've used the append function and I've given the value that I want to add to my array. As you can see in the output, 3.4, which is the value I've specified to the append function, has been added to the end of my array which is A. And then I've used the extend function. Please make a note over here that when you use the extend function, you will have to specify the values between square brackets. If you don't use the square brackets, it will throw an error. I've given 3 new values and all 3 values have been added to the end of my array. And then I've tried to use the insert function. Over here, I've specified the index number as 2 and the value to be inserted at that position as 3.4. As you can see in the output, 3.4 has been inserted at C of 2. Now let's go to our Jupyter notebook and we'll do the same. I'll reprint my array which is A so that it's easy for us to refer to it. Since my array A holds integer values, I will give some new integer value to it. As you can see, I've given 8 as the value that I want to insert in my array, and 8 has been added to the end of my array. Now let me try to give some float value to this array and see what happens. As you can see, when I try to append some float value, it gives me a type error. Therefore, I can add only those values which is specific to the type of elements that are present in that array. Now let me try to use the extend function. Like I've told y'all, when you're using the extend function, you will have to make use of the square brackets. As you can see in the output, all the values that I've specified within the extend function have been added to the end of my array. Now let me use the insert function. I've used the insert function and the first parameter I've specified is the index value and the second is the element to be inserted at this index position. So at index value A of 2, 6 will be inserted. As you can see in the output, 6 has been inserted at A of 2. So I hope you're clear with how to add elements to an array. Now let's move on towards the next operation. Our next operation is removing elements of an array. In case you want to remove elements from an array, you can make use of the pop or the remove function. The pop function removes the element and returns it, whereas the remove function will remove it but it will not return it. The pop function can either take no parameters or one parameter. The parameter it takes is the index value of the element to be removed. If you do not specify any parameter, it will remove the last element from the array. The remove function takes one parameter, which is the element to be removed itself. Now let's have a look at a small example of this. As you can see on the screen, I've created some random array A, and then I've used the pop function without specifying any parameter. As you can see in the output, when I do not specify any parameter, the last value present in my array has been popped and returned as well. Second time, I've used the pop function and I've given some index value. Now this pop function will remove the element that is present at this index position. As you can see, it has removed 3.1 and returned it as well. After that, I've used the remove function. Like I've told you before, the remove function takes one parameter, which is the element to be removed. And you can see in the output that the remove function has not returned any value. After that, I've printed my array. And you can see all the values that are removed using these two functions are no more present in the array A. Now let's go to our Jupyter notebook and do the same. Let me reprint my array, which is A. First, I will use the pop function without specifying any parameter to it. As you can see over here, when I do not give any parameter, it removes the last element that is present in my array. Now let me give some index value to it. I'll reprint my array A because I've removed an element from it. Now let me give some index value to the pop function. As you can see, when I use a.pop of 2, it removes the element which is present at a of 2, which is 6, and it returns it as well. Let me try to use some negative index value for the pop function. a.pop of -1 removes the last element that is present in my array, which is 5. Now I'll use the remove function. Let me reprint my array, guys. As you can see, all the elements that have been removed using the pop function are no more present in my array A. Like I've told you before, when using the remove function, you will have to specify the element that is to be removed. Here, let me remove 8, because there are two occurrences of 8. And let's see what the remove function does. When I hit run, remove function does not return anything. Now let me print my array A and see what is present. As you can see, the first occurrence of 8 has been removed, but the remove function did not return the value. So I hope you're clear with the remove and the pop functions. Now let's get back to our presentation and perform the next operation. Our next operation is array concatenation. Concatenation means joining. So in case you want to join different arrays, you can make use of the plus symbol. As you can see on the screen, I've created some random array A and B, and then I've created some random array C, which is empty. Also make a note that all three arrays have the same type code. And then I've concatenated A and B into my empty array, which is C. As you can see in the output, all the elements present in A and B have been concatenated into my array C. Now let's go to our Jupyter notebook and perform array concatenation. I'm using int as my data type. You can use any data type of your choice. To create an empty array, all you have to do is specify the type code and leave the value list empty. Here I've created an empty array D and I've concatenated B and C into my array, which is D. Now let me hit run. When I hit run, all elements present in B and C have been concatenated into my new array, which is D. So I hope you're clear with array concatenations. Let me just show you what happens if I try to concatenate arrays of different data types. I'll just change one of my previously created arrays type code and I'll give it as float. Let's see what happens when I change the type code and I try to concatenate these two arrays. You can see that I've encountered an error and it says type error, which means it cannot concatenate two arrays of different data types. So just be careful when you're concatenating arrays. You cannot concatenate arrays which hold different data type elements. Okay, now let's move on towards our presentation and see what is the next operation. Our next operation is slicing an array. Slicing actually means fetching some particular values from your array. To do so, you can make use of the colon symbol. As you can see on the screen, I've created some random array A and I've sliced it from 0 to 3. 0 specifies from where fetching has to start and 3 specifies where it has to stop. So, it will start from 0, it will go on till 3, but it will not include the value which is present at 3. As you can see in the output, I have A of 0, A of 1 and A of 2 that is present in my output. Now let's go to our Jupyter notebook and we will try to slice our arrays. I'll reprint my array D over here and then I will try to slice it. As you can see, I've sliced my array from 0 to 5. So it will start from index number 0, it will go to 5, but it will not include the value which is present at index number 5. You can also see the same in the output over here. Let me try to use some negative index value. My output when I use 0 colon -2 contains all the values between 0 and -2, but it will not include the value which is present at -2. Okay, so I hope you're clear with this topic. Just give me a quick confirmation before I move on. Okay, Anil says yes. Shashank has a question. He asks, what does colon colon -1 mean? Shashank, unlike what many of us think, colon colon -1 does not reverse my array, but it prints a reversed copy of my array. So let's try to do this over here. As you can see, all the elements present in array D have been reversed. Now let's print our array which is D. The original array D is the same, but colon colon -1 has reprinted a reversed copy of my array which is D. This method is actually not preferred because it exhausts the memory. So I hope I've cleared your doubt, Shashank. Just give me a quick confirmation. Okay, Shashank says yes. Now let's get back to our presentation and perform the last operation of this session, which is looping through an array. You all might be familiar with these two loops, which is the for and the while loops. The for loop iterates over the items of an array specified number of times, whereas the while loop iterates until some condition is met or some condition is true. When you're using the while loop, you will have to keep three things in mind. One is initializing your iterator. Second is to specify a condition. Third is to increment your iterator. Remember that if you do not increment your iterator, your while loop will go on forever. Let's see a small example of this. As you can see on the screen, I've created some random array A, and then I've used the for loop to loop through my array A. I've used for x in A print x, which means go to every element that is present in A and print it. Let's try to do the same on our Jupyter notebook. Let me reprint my array D. Now let me use the for loop to loop through this array. For x in A, print x, which means go to every element in D and print it. As you can see, all elements present in D have been returned one after the other. Now let me try to slice this array and print specific elements. As you can see over here, I've sliced my array from index number 0 to -3 and I've printed only those specific values using the for loop. Now let's go to our presentation and have a look at the while loop. Like I've told you before, when you're using the while loop, you will have to do three things. One is initializing your iterator. Second is to specify the condition. And third is to increment your iterator. Let's try to perform looping on our Jupyter notebooks. Please do it along with me, guys. Let me reprint my array D. Here I'm using the iterator as temp. You can use any name of your choice. As you can see over here, I've initialized my iterator to 0 and then I've specified a condition wherein I have told whenever the value of my temporary variable is less than d of 2, then print that value. And then I have iterated the value of temp. I can also use temp plus equal to 1, which is same as temp equal to temp plus 1. Now let's try to use the while loop using the len function. Here I will use my array A. So let me reprint it over here. As you can see over here, when I use the len function, my temporary variable will go to all elements present in my array A and print them one after the other. So I hope you're clear with looping. Okay, so this was our last topic for today, guys. So I hope you've learned something new in this session. Goodbye and take care.